We're gonna learn about 14 Dart concepts for the solid foundation. So Dart is the foundation. So the concepts of Dart are the building blocks. So you need them to understand before you can effectively use Flutter. So we're gonna learn about it, okay? And here we're gonna learn about Dart programming language, how the Dart programming language works. So what are functions, importing features from packages, value types, variables, immutable variables, final and constant, generics, list, classes, objects, constructor, functions, splitting code across multiple files, and instance variables. So how the Dart programming language works is first, to understand how Dart programming language works, we need to understand how source code is translated to machine code. Okay, so you have a source code. So source code, this is the code you write, like for example, this is the code, right? So in any programming language, like you write a code, so this is the source code. Then the compiler or interpreter, this is the program that translates your source code into the machine code, okay, like 01000, okay. So this is the lower level code that your computer process can directly execute. It is a sequence of binary instructions that I already, this is the binary instructions, okay. Then the process of there is a compilation process happening, that is the process of translating source code into machine code before the programmer is run is the compilation. And finally the interpretation, the process of translating and executing source code line by line is called the interpretation. So this is how the source code is translated into machine code. And then there is a Dart compilation, AOT, that is ahead of time compilation, and JIT, so just in time compilation. So ahead of time compilation, or AOT, in Dart means like your Dart code is translated into machine code before your app runs, okay. So the benefit are like you have a faster startup times, you have a predictable performance, you have optimized for which is optimized for production. You have a release build for Flutter apps are ahead of time compilation. Then you have a just-in-time compilation. So this means that Dart code is translated into machine code as our app is running. So the benefits are hot reload changes are reflected in the running app almost instantly. Then you have a faster development cycles, and then you have a development builds for Flutter app. So this is just in time compilation. So you are gonna the use case of just in time compilation is like the development, you are building the app, Flutter app in development build, okay. So let's understand the Dart programming concepts here, the fundamental concepts, core concepts. So what are functions? The functions, as you can see, okay, let me just remove this. So functions are it has a return type, okay. As you can see here it's a return type is void. Then you have a function name, main is the function name, and then you have a here you can put the parameters, like parameters type, okay. So it can be integer, so this is a parameter type, and your parameter name, okay. So similarly you can have multiple other parameters like int b, okay, something like, but here your main cannot have any parameters, okay. So here you can create int add function int a int b, okay. Then sum equals to a plus b, and sorry okay, return the sum, okay. So it's pretty simple. So this is a simple function that is just doing the performing the action of a summing, adding. Then let's print out. Okay, so if you run it, your sum is 5, okay. 3 plus 2 is 5, obviously. So this is a simple example of a function. Then let's learn about the position positional arguments. So arguments passed to the function based on the order in the function definition are positional arguments. Okay, so here the positional arguments are a and b, right? So what are the named arguments? And arguments passed to function by their name. We use curly braces in the function definition. Is we use a required a key word to make a named argument mandatory. Okay, so let's create a simple example. Let's create a function that's called print details. We have a required named argument like name and required is okay. Then what we're gonna do, we're gonna print name is a name and is gonna be is. Okay, so let's go back to here and let's call the function print details. Okay, we have to just assign it, we have to declare it before. Okay, so print details name is is 20. So let's print it out and say name is Bobby and age is 20. As you can see here, we are just, if we don't pass anything, then it's gonna give an error, right? The name parameter's name is required, so it is required, you know. So this is the named arguments. Okay, so let's deep dive into the positional arguments versus the named arguments. So the pros of the positional argument is it's a concise syntax, whereas the name arguments is more readable, self-documenting and order independent, right? So the cons of named argument is like it can be like positional argument is it can be confusing if there are many arguments or if the order is not obvious, right? So the cons of named argument is slightly more verbose. Okay, so you can use for simple functions with the few arguments where the order is clear, whereas for the use case for the named arguments is like it is used for functions with many arguments or when you want to make the code more readable. Okay, so okay, let's move further. So we learn about functions as a value. Functions are the first class citizens here. So this means you can assign functions to variables, pass functions as arguments to other functions, and return functions from other functions. So to demonstrate that, let's create a simple example. Operate int a, int b, int function, int operation, int result, so operation b, print the result. So we add int a to b. So you see this is like you can assign the value directly to a function, right? Okay, so finally we can just pass the add function to operate 10. Subtract. Okay, let's run this. So if the result is 15, if you add it, if you subtract it, the result is 3, and that's correct, as you can see here. So this is the simpler demonstration of the function as a values. Okay, so as you can see here, so you can also import packages, features from packages. So you can collect so packages are the collection of pre-written code that provides specific functionalities. So why we use package is like to save time, extend functionality, like for also for the community support. And their types of packages are SDK, like you have a built-in packages like Dart, Matlaw, IO packages, Math packages. Okay, so you can also have external packages from the pubdev repository. So to demonstrate this, I'm gonna create import the simple Dart math package. So you have the square root of 5, and you have a you can print the square root. Then also you can use the http get parse the https. Yeah, you see the square root of 5 is this is 1. Okay, so you can also similar, this is the demonstration how you can use the http dart package. Okay, that we can but this is how you can use the packages. You can import the package, okay, then use them. So let's learn about the value type, the foundation of data. So value types is used to represent different kinds of data. So these types define the nature of the data and the operation that can be performed on it. So we have integers, like this way, and you have a floating point numbers like double price is 99.20. Then you have a string, okay, then you have booleans, right, this package. Okay, so you can also variable store and managing the data using the variables. Variables are named storage location that holds data, so they are essential for manipulating and working with information in your program. So you can declare variables um, of a specifying its type, or using var for type inference following its name. Okay, so you can use a specific variable of a type as you can see here, and this is the example. Or you can also specify by type inference. So you can see city is London. So it is all automatically type inferencing, and it is knowing that this is of type string, right? So you can initialize the variables, as you can see here. So I have just initialized the variable here, where you can or you can just declare it later by using let init, okay, or let okay, as you can see here, this is using the let init. Okay, you can initialize the variable later. So each variable has a type. So as you can see here, the type determines the kind of the data the variables can hold. So once the variable type is established, it cannot be changed. Okay, so it's type safe language. Dart is a type safe language. There are two special keywords, final and constant, which are the immutable variables. So these are used to create variables whose value cannot be changed after they are assigned. So final string app name, my app name. Okay, so this cannot be changed, so it's already final. Okay, for similarly we have also a constant, the is 3.14415. okay, so this is also constant. So this value is known at the compile time, so that value must be assigned. Okay, so constant values are evaluated during compilation. So this means that the compiler can optimize your code by replacing constant variables with their actual values directly. So this can lead to performance improvements. Okay, so similarly we also can have a generic, that is that helps you to reuse code with a type flexibility. So you can write a code that can work with different data types without sacrificing the type safety. So so you define a generic type using an angle bracket and a type parameter. Okay, so let me give a simple example. Box so we have a main. Okay, so you can have a box of type integer, then pass the value 10, or also you have a box of type string, okay, so you can print int box value, or you can also print string box value. So let's run this, let's check it out ourselves. So you have a int box, that's the value is 10, and the string box, that value is hello. Okay, so this is the simple example of generics. So you can have an ordered collection of data, you can create a list. So let's also create a simple list. Example of a simple list is pretty simple: string list of type integer, numbers 1 2 3 4. okay, so you can print the numbers. So this is a simple example of a list. Okay, so you can also manipulate the list, like you can numbers dot add 5 to the number, and you can print the numbers again. Okay, you see previously the number is 4, and then after adding the number is change to 5. So similarly you can also do remove, add, insert, you know, multiple other. You can also iterate over the list, like for int number in numbers, you can print the number. Okay, so let's run this. You see it's iterating with over the numbers list. Also similarly you can use the for each. For each is also similar, so you have numbers for each, then you can have a number, print the number. Okay, so if you see it's doing the same thing, right? Okay, so you can also have a class. So class are the blueprints of for objects, so define the properties, data and methods behavior that objects of that class will have. So to understand the class, let's create a simple example of a class, dog. So you can have a name of a dog, you can have also the function. So okay, so this is a simple example of a class which consists of the methods and also the the parameters, the variables and also the methods. Okay, so you can create the instance of the box object, like dog object. So dog, my dog will be like assigned to dog. Then similarly okay, okay, you call the method. Okay, so if you run oof oof, so your dog is calling the method bark, right? You can also have a constructor parameters, like a dog can have a constructor like a string name. So this dot name is a name, so you can directly here also name of the dog is boom. Okay, you don't need to assign it here. Okay, and you can print the dog name. Okay, my dog dot name. Okay, sorry. Okay, boom woof woof. Okay, that's it. So you can also have multiple constructors. Okay, so this is one constructor. You can have other constructors like dog dot unknown. So you can have also unknown dog, which is assigned to name is okay. So you can also have a dog dot unknown. Okay, so to create the unknown dog. Okay, it's similar, so it's simple. Okay, so finally some key tips for success are like you can so list or order collections of data, providing methods for manipulating and iteration. So for code organization, you can split the code into multiple files, improves the maintainability and readability, whereas objects are instances of classes representing concrete entities. For generics, it helps you enable you to write reusable code that works with different types. For classes are blueprints for creating objects, defining their properties and behavior, whereas the value type darts, fundamental data types, int, double, string, bool. forms the basics of all data. So variables store data and are essential for manipulating the information. You have a final and constant keywords. This creates immutable variables with constants being evaluated at compile time. For constructors, you can initialize the constructor objects when they are created, and um, instance variables are object specific data with each object having its own copy. Okay, so these are some core ideas, fundamental ideas of Dart. So I hope this practical implementation is gonna help you, and thank you guys.